So if we have to draw a circuit diagram, let's say I have a bulb, I have a resistor, and here I have a switch. Okay, here I have a battery. Then we can place an ammeter over here. Okay, and this is closed. Now, as I was saying that ammeter is connected in series and voltmeter is connected in parallel, what I meant to say by that, let us understand over here. In this diagram, you can see that this resistor is there. Na? So let's say if I want to measure voltage across the resistor, voltmeter, main purpose of voltmeter is to measure the voltage. Main purpose of ammeter is to measure the current, and this will measure the voltage. Okay, so if I want to measure voltage, I will always measure it across a certain device. So let's say if I want to measure voltage of this resistor, I will apply voltmeter like this. So in a similar fashion, voltmeter can be applied anywhere across the devices. Now it is obvious that we cannot apply voltmeter across the ammeter. Ammeter will not have any voltage. It is just a device showing certain readings of current. So voltmeter can be applied across a resistor. It can be applied across the bulb, okay, or any other circuit element. Just to show you that these are all symbolic ways with which we draw the circuit diagram. It is not fixed that you have to apply voltmeter like this. You can even apply like this also, okay, but it should be applied in parallel. So the way voltmeter is applied over here, that is called as parallel connection. Okay, it might be new term for you, so just observe and try to understand. Parallel means parallel to the resistor, we are applying a different set of wires, and in that we are joining the voltmeter. Parallel to the bulb or the lamp, we are applying voltmeter. Now, if you look at ammeter, it will make more sense that why we are calling that in series. Whenever we say series, so series means it will be connected in the main circuit. So here, this ammeter is connected in series, because it is not applied across any other device. It is applied or it is connected in the main circuit. So we call that connection as series connection. Then we have a battery. So battery will supply certain voltage. That voltage is, let's say, V, and this is the key or the switch. Okay. Now let's say a switch is closed. So current will start flowing in the circuit. Okay. For now, I'm removing one of the voltmeter. We'll keep voltmeter only across a resistor. So current will start flowing in the circuit. The current always flows from positive terminal of the battery to the negative terminal. So this is the direction of flow of current. Okay, in the whole circuit, the current will flow in clockwise direction for this particular circuit. Clockwise direction is not a fixed concept. Okay, it is just with respect to this diagram. If I reverse the terminals of battery, then direction of current will be reversed. So till here, do you have any question?
No.
I hope you are making the diagram also along with me.
I am.
Okay.
I am.
Now, when current passes through the lamp, okay, when current will pass? Current will pass only when you close the switch. Okay, remember, open switch means circuit is not working. Closed switch means circuit is working. So when you close the switch, the current will go in the lamp. Lamp will start working. Okay, the intensity of the lamp will decide the intensity of current, the amount of current. So that cannot give us any value. We can just say that current is more or current is less, current is fluctuating. Okay, but when the current passes through this ammeter, because this is just like a wire, so it will pass through ammeter also. When it passes through ammeter, ammeter will give you a certain reading of current. Okay, so it's like a measuring instrument which will give us a proper reading, and that reading will ensure that, okay, the current in the circuit is this much. We have formulas also to measure that current that we will discuss later. But for now, the purpose of ammeter is to measure the current. Okay, now when it measures the current, current is represented by I, okay, and the unit of current is ampere. It is written as amps, okay. In short, we call it as amps. So let's say if the current in the circuit is 5, so we call it as 5 amps or 5 ampere of current. Okay, so it depends from circuit to circuit, and the current requirement for every device is different. So because of that, each and every device have a circuit element as a gatekeeper, that when current enters that device, okay, just imagine TV. So when current enters TV, the same current is entering TV also. The same current is entering in your water purifier also. The same current is entering in your AC also. So just imagine that current is supplied from one source, but the same amount of current is going in every device. So don't you think that it
No.
can create trouble for all the devices?
Not the same current would go into all the devices though, right?
So the same current will go in all the devices, but because each and every device have different requirements, then they will alter the value of current.
Yeah, that's what I meant.
Okay, so that thing is done by a device called as transformer. Okay, transformer is normally, like when we broadly speak about the value of current or the value of voltage, we apply transformer in a particular area. Okay, from power generation source, when current comes, the voltage comes in the form of a wire, like through the wire when it travels and come. So it is always a high voltage. Then it drops down with the help of a transformer, and then it goes in the houses. In houses, in every device, we have small transformers, which will alter the value of voltage, hence it will alter the value of current. So gradually in the chapter, we are going to learn about all these aspects. Right now, I'm just giving you a glimpse. Okay. Moving on, when this current will pass through the lamp, it will go in the resistor. As soon as it will go in the resistor, the reading of the resistor is R. Okay. Reading means the value of this resistor is R. Resistor is measured in ohms. Okay. This symbol is called as ohm. Okay. Once again, it's a Greek letter and this is called as ohm. So when current goes in the resistor, since voltmeter is applied across the resistor, this voltmeter will start showing some reading. Okay, and that reading of a voltmeter will actually give me that how much voltage is there across this resistor. Voltmeter will never give you the reading for the full circuit, that how much voltage is there in the full circuit. That you can see from the battery, that what battery is supplying, that will be for the full circuit. Voltmeter will give you reading across that element to which it is applied. Okay, that reading will come in volts. V is the short, we can say, symbol for that, or the unit for that, and this is called as volt. Okay, so this is how the whole circuit works. This is a very rough interpretation of a circuit diagram where we have seen all major circuit elements.